All right, in 7.4, we are going to see what happens when you multiply t to a power times your function. We've done e to the negative something times your function. Now we're going to look at the Laplace transform of t to a power times a function of t. The formula for that involves a derivative. It is going to be negative 1 to the nth power times the nth derivative with respect to s of f of s. Alrighty, now let me try to explain to you what this means by looking at a couple of examples. Try to make this one. See. All right, this is the first problem in your book. Problem 1 is t e to the negative 10t. And we're going to use this formula for doing this one. I realize, and you may realize if you tried to do this, that there's another way to work this problem. But I'm going to try to use it with the t to a power times a function. That's what I'm going to do, okay? So in this particular problem, my n is 1, because my exponent's 1, and my function, my f of t, is e to the negative 10t. So what I'm doing is taking the Laplace transform of e to the negative 10t. So the Laplace transform of e to the negative 10t, you've got a formula for that, is 1 over s plus 10, I do believe. 1 over s plus 10. But this formula up there says if I've got t multiplied times a function, then I need to take negative 1 to the nth power, which is the first power, times the first derivative with respect to s of 1 over s plus 10. So the Laplace transform is negative whatever this derivative is. You could use your calculator for derivative or whatever, but if I did bottom times the derivative of the top minus the top times the derivative of the bottom over the denominator squared, then this is going to give me, that's 0. This is going to give me 1 over s plus 10. The whole thing is squared. And that is the Laplace transform of t e to the negative 10t power. So whatever this exponent is, that's how many derivatives you have to take. Okay? All right, let's look at another one. Let's look at, this is number 6 out of your book. The Laplace transform of t squared times the cosine of t. Alrighty, in this one, your n is 2. So this means you're going to take negative 1 squared, and you're multiplying it times the derivative with respect to s of whatever the Laplace transform of the cosine of t is. But it's the second derivative. Because n is 2, you're taking the second derivative. So negative 1 squared is positive 1. So I'm going to need second derivative of whatever the transform of cosine is. The transform of that is 1 over s squared plus 1. So I need to take, it's s over, I'm sorry, you're right, I was doing sine. Thank you. That's what I mean by I need to look. It's s over s squared plus 1, sorry. All right, so you need to take the second derivative of this. Your calculators will let you do this. You do not have to do this by hand. So I would pull out my trusty calculator and I would do a second derivative. Hold on, the derivative of all right, and I got it to be 2s s squared minus 3 all divided by s squared plus 1. And that is your Laplace transform. Okay. You always hope that this is not a very large exponent because you don't really like to take a lot of derivatives, but with calculators it makes it a lot easier. Okay. All right, let me look at one like number 8 because it combines several different things. This is t e to the negative 3t cosine of 3t. And you're taking a Laplace transform. All right, you've got two things going on here. You've got the t, which involves the derivative function. And then you've got e to the 3t multiplied times cosine. So you've got a couple of things going on. All right, the way I would break this up is let this be my f of t. So what I'm doing again is I'm doing negative 1 to the first power times the first derivative with respect to s of whatever the Laplace transform of e to the negative 3t cosine of 3t is, whatever that is. Everybody following? All right, so now I got to figure out how to take the Laplace transform of this one. Well, I have a formula for that one. The Laplace transform of this shifts it. Remember, 3 units. So in this particular thing, a is negative 3. So I take the Laplace transform of the cosine, which is s over s squared plus 9. But then I have a shift, and the shift means I need to take f of s minus this, which is s plus 3. So this is s plus 3 over s plus 3 squared plus 9. But that's what I got to take the derivative of. So this is going to be negative 1 times the derivative with respect to s of this creature right here, which is s plus 3 over s plus 3 squared plus 9. And I do not know what it is. You do it by hand or a calculator. And my calculator spits out opposite of this s times s plus 6 over, and it went ahead and foiled the denominator out, but what it is s plus 3 squared plus 9, and all of that is squared. Mine foiled it out, but this is the form. I'm not sure what WebAssign takes. It probably takes it all foiled out. I'm not sure. All right, are we okay with this so far? All right, now, if you're taking Laplace transform, you know you got to take the inverse. You got to go backwards. All right, the formulas for that are going to be in Appendix 3 in your book. Appendix 3, and I don't know what page that is on. Back. Pardon? Oh, does it? Great. Well, I don't have a link to it, so it's back here on my page, AP 22. All right, so you're going to have to find the correct formula when you're taking the inverse, okay? So let's look at a couple of problems where you're doing that. And they put them in initial value problems. And now I've flipped off the page that I need. Yes? Okay. So that's what they put it on there for you? Okay. All right. The problem that I'm going to look at involves an initial value problem, which is where all this is going to take place. I'm going to look at number 12 out of your book. Number 12. So y double prime plus y is equal to the sine of t. You know that y of 0 is 1 and y prime of 0 is negative 1. All right, take the Laplace transform of both sides. All right, Laplace transform of y double prime. S squared y of s minus s y of 0 minus y prime of 0 plus y of s equals Laplace transform of the sine. This one is 1 over s squared plus 1, right? All right. Y of 0 is 1. Y prime of 0 is negative 1. So if I keep my y of s's together, I have s squared plus 1 times y of s minus s plus 1 is equal to 1 over s squared plus 1. When I solve everything, this is going to be s minus 1 plus 1 over s squared plus 1. Y of s is s over s squared plus 1 minus 1 over s squared plus 1 plus 1 over s squared plus 1 squared. Everybody with me? All right, now I'm taking the inverse Laplace transform to get my function. These first two are just normal. There's nothing weird about these. You just look those up in your chart. So to get your function y of t, this one with s on the top is the cosine, minus this one, which is the sine of t, plus. All right, for this one, you have to find the correct form, and you're looking for something squared plus something squared squared. It does not have an s on the top, so make sure you find one that does not have an s on the top. It looks to me like it's number 25. It looks to me like it's number 25, where it has 2k to the third over s squared plus k squared, and all of that is squared. This is what the book has on number 25. All right, in this particular problem, k is 1. But there's a 2 that I need on the top of my problem that I do not have. So if I put the 2 here, I need to pull a 1/2 out, so I'm going to have 1/2 times. All right, going back to number 25, the sine of t minus k times t times the cosine of t. And this is from number 25. And then you can combine some of this. Cosine t minus the sine of t plus 1/2 sine of t minus 1/2 t cosine of t. Those two combine, and I have the cosine of t minus 1/2 sine of t minus 1/2 t cosine of t. And that is your answer. Yes?
One question on number 8. What do you think would be an appropriate formula for A?
Did I work problem 8?
Yeah.
I did?
Yeah.
I'm just looking for it. Is this number 8? Is this number 8?
Yeah.
And you're asking what would be the most appropriate formula for that? One that involves e to a power and a t to a power, if there is one. And if there's not one, you've got to combine them, just like I did. I see an e to the at, I see number 18, which got us to right here. Right, 19. But then it doesn't have the t in front of it, so you're still going to have to do the t yourself. So there's not a formula that takes all the way. There's a formula that did part of it, but not all of it. Okay, what else? All right, let's look at another one of these. Let's see. All right, number 14 involves a step function, unit step function, so let's do that. It's probably got a little bit of everything in it. All right, it's y double prime plus y is equal to f of t. Y of 0 is 1. Y prime of 0 is 0. And f of t is 1 when t is between 0 and pi over 2, and it is the sine of t when t is greater than or equal to pi over 2. Okay, so the first thing you got to do is write this as a unit step function. Okay, got it written down. So to write this as the unit step function, f of t is 1 plus the sine of t minus 1 times your unit step function at t minus pi over 2. All right, everybody remember how to do that? All right, you're fixing to take the Laplace transform of both sides, so let's go ahead and take the Laplace transform of this f of t business. All right, Laplace transform of 1 is 1 over s. All right, this all involves a unit step function. All of this involves the unit step function. So when you're taking the Laplace transform of that, my unit step function, I'm going to have e to the negative pi over 2s multiplied times the Laplace transform of the rest of this shifted. So I need the Laplace transform of the sine of t plus a, which is pi over 2. Okay, y'all looking at your formulas? This is my g of t. I need the Laplace transform of g of t plus a. This will simplify. The sine of t plus pi over 2 is the same thing as the cosine. This simplifies to the cosine of t, which is s over s squared plus 1. So this is s over s squared plus 1 minus, I need the Laplace transform of 1, which is 1 over s. There is no t plus a here, so it's just 1. Is there a question about what I did here, or do y'all see anything that I did wrong? Alrighty, take the Laplace transform of the other side. So s squared y of s minus s y of 0 minus y prime of 0 plus y of s equals all this other stuff. Okay, initial conditions. Y of 0 is 1. Y prime of 0 is 0. s squared plus 1 times y of s, that takes care of those, minus s, move it to the other side, it becomes s plus 1 over s plus e to the negative pi over 2s times s over s squared plus 1 minus 1 over s. You stop right now and make sure everybody's with me and that I hadn't made a mistake. Okay, divide everything by s squared plus 1. S over s squared plus 1, 1 over s and s squared plus 1, plus e to the negative pi over 2s times s over s squared plus 1 squared minus 1 over s and s squared plus 1. Okay, I would put this in a calculator and expand it. Right there. None of that involves a shift. That's just going to be normal. So I would expand that and get common denominator, get everything else set up together. That's what I would do. If we expand that. All that simplified to 1 over s. S over s squared plus 1 over s squared plus 1 simplifies to 1 over s, which makes that a whole lot easier. I would leave this one alone. I would probably go ahead and expand this fraction right here also. I'm just going to have a bunch of 1s on top of it. Oh, I should have started all over. I have minus 1 over s plus s over s squared plus 1. Does that look like something that you guys got? Yes? Okay. So, Baylor, you look like you got a question.
Yeah. Where are you getting the 1 over, the minus 1 over?
This?
Yeah.
Because when I typed in negative this, my calculator told me it was negative 1 over s.
Okay, expanded.
That was the expanded form,
Okay.
yes. Yeah, I expanded this one right here. Because I knew I was going to have to eventually anyway, so I went ahead and did it. So then you do your inverse Laplace transform. 1 over s is, it's 1 over s. Isn't it just 1? Alrighty, then we've got e to the negative pi over 2s. This is an inverse Laplace transform. I've lost my formulas. Yikes. Oh, here they are. Inverse Laplace transform. When you have e to a power, this is the unit step function. So I'm going to write it in front, which is not really what I'm supposed to do, but I'm going to write it in front so I don't lose it, because everything behind it's got to be shifted or multiplied by my step function. So I've got that. Okay. Laplace transform of this one, or inverse Laplace transform of s over s squared plus 1 squared. That one is a formula from your appendix. It's got an S on the top. So I think it is, okay, yes, 22. Yep. By 22, I need a 2 on the top. So I'm going to have 1/2 t sine of t. But when I put it in my answer, remember your formula says that you have to do, this is f of t. You need f of t minus pi over 2. So that's going to be 1/2 t minus pi over 2 times the sine of t minus pi over 2. And this would probably simplify, it's probably negative cosine or cosine. Sine of negative cosine. So that's 1/2 t minus pi over 2. I'll stick the negative in front. Cosine of t. So that's going to go first. All right, the Laplace transform, or inverse Laplace transform, sorry, of 1 over s is just 1, and there's nothing to shift there, so it's just a 1, plus our inverse Laplace transform of s over s squared plus 1. That's just normal. That's the cosine of t. But this is f of t again. You need f of t minus pi over 2. So you need the cosine of t minus pi over 2, which is negative sine t. And that is your answer, and it kind of combined a little bit of everything. Okay, what questions do you have?
So on the inverse, you pretty much just need to look at the table.
Yes, for this.
Mm-hmm.
Yes, anytime you have a squared, look on the table. In fact, most of the formulas that we've done are in this table, except I was looking to see if they had the derivative formulas, and that they don't. Well, actually, they do have some of them back in here. Right back here. And I don't know if they included that on your WebAssign link or not.
Yeah.
They did not?
It's only
Right. See here,
oh, maybe
this is 50 to,
They have it.
well, we're not doing these right here. But here's the one we did today.
Yeah, they have all.
Okay. There's the derivative today. There's how you take to a bunch squared or whatever. So there's the rest of the formulas right there at the end of the page. So you will have all those. Oops, sorry. Okay, is there anything else?